Next question. Which one of these hydrogen atom spectra are observed in the visible region? So, the spectra of hydrogen atom is observed in UV region, visible region, and also in infrared region. The high energy radiation will be observed in UV, and next visible, and next infrared. So the option given here is option A, n equal to 3 to n equal to 2, and B, n equal to 4 to n equal to 3, C option n equal to 2 to n equal to 1, and D option n equal to 5 to n equal to 4. We want to say which will be observed in the visible region. So, when n1 is equal to 2, that is any transition where n1, that is from which orbiter the transition is happening, when n1 equal to 2, it will be in the visible region. Such transition from n1 is equal to 2 are called Balmer series, and so the first option, that is n equal to 3 to n equal to n1 equal to 2 is observed in the visible region because it is a Balmer series. When n1 equal to 1, it will be Lyman series, and after that it will Lyman series will be observed in the UV region, and n1 equal to 2 is observed in the visible region. It is a Balmer series. Rest will be observed in the infrared region. So our correct answer will be n2 equal to 3 to n1 equal to 2. It is observed in the visible region. Next question. It is a generally related to a physics-based question. Identify the graph which shows variable positive acceleration. The 4 graph is given here. We want to see which will be the graph that is showing positive acceleration. So here we can see the first graph. It is the particle is moving with uniform velocity. They do not have a constant velocity, but the velocity is changing uniformly. So there will be no acceleration here. So the acceleration graph will be constant. But the question asked is positive variable acceleration. So next also, the acceleration is will be a constant here, but in the C graph we can see the velocity and time graph is exponentially increasing. So that for that particle it will have a variable positive acceleration. So the correct option will be option C. That graph represent the particle that is moving with a variable positive acceleration. Next question. The gases A, B, C, and D obeys the van der Waals equation, and with A and B values are given here. So 4 gases are given here, that is A, B, C, and D, and the value of A and B are also given here. So we want to see which gas will have the highest critical temperature. Option A, gas A, option A, gas B, and option B, gas C, option C, gas A, and option D, gas D, which will have the highest critical temperature. So according to van der Waals equation, we know that critical temperature of a gas is given by the equation. Critical temperature is equal to 8A by 27 RB. So the TC is proportional to A by B value, and here we can see the A value of all the gases is 6, that is same, only the changing value is B, and the TC is inversely proportional to the value of B. So the gas that have the lowest B value will have the highest critical temperature. So in the graph it is seen that A gas will have the lowest B value, that is 1, compared to other gases. So the gas A will have the highest critical temperature. So our correct answer will be option C, that is gas A. Next question. Calculate the number of molecules with the translational energy E trans is equal to 3.0 kT relative to that with the E trans is equal to 2.0 kT, and given the value of E is equal to 2.72. So we want to see the number of molecules with the energy 3.0 kT to energy 2.0 kT. Option A is 0.37, option B 0.61, option C 1.64, and option D 2.72. We want to see which will be the correct answer. So here we want to apply Boltzmann equation, that is n is equal to n0 e raised to minus E by kT, where E is the energy and n0 is the total number of molecules, and N is the number of molecules which having that particular energy E. So if we want to find the number of particles that molecules having the energy E 3.0 kT, we want to substitute this in the equation, that is N1 is equal to N0 e raised to minus 3 kT by kT. So it will become N0 e raised to minus 3, and for N2 we want to see N2 is equal to N0 e raised to minus 2 kT, that is the energy of the second state divided by kT. So when we are we are going to find the ratio, it is asked that we have to find the ratio. So N1 by N0, N1 by N2 is equal to e raised to minus 3 by e raised to minus 2, that will be equal to 1 by E. Here it is given that the value of E is equal to 2.72. So when we are substituting the value, we will get 1.2.72. So the answer will be 0.37, and our correct option will be option A, 0.37. Next question. The reaction between hydroxide ion OH minus and the phosphinate ion H2PO2 minus is given here. H2PO2 minus aqueous plus OH minus aqueous gives H2 gas plus HPO3 2 minus aqueous. Has been studied by following the initial rate of formation of the gaseous product, and the results are tabulated below. So the total details of the, if we want to find the rate of the equation, it is based on the chemical kinetic chapter. So initial concentration is given here, and initial concentration of OH minus is given in other table, and the initial rate of evolution of H2, that is the rate of the reaction, how it is affected, is given in the third row. Third column. So we want to find what is the overall reaction order. So the reactants used here is phosphinate ions and hydroxide ion. We want to see how the concentration of these two alter the rate of the reaction. So what is the overall reaction order? Option A is 1, option B 2, and option C 3, and option D 4. We want to find which will be the right answer. So when we are taking when we are talking about the concentration of OH minus, so in the first two rows we can see the concentration of phosphinate ion is constant, that is 0.6, and here we can see the concentration of the hydroxide ion is doubled. So when OH minus concentration of OH minus doubles, the rate quadruples. Here we can see when the concentration of OH minus is 1, the rate is found to be 2.3, and when it is changed to 2, the rate changes to 9.5. In both these cases, the concentration of phosphinate ion is constant, that is 0.6. So when the concentration of OH minus doubles, the rate become 4 times, that is 2.3 into 4 equal to 9.5. So we can say that rate is proportional to square of the concentration of the hydroxide ion. And in the next two rows, we can see the concentration of hydroxide ions is constant, that is 6.0. And the concentration of phosphinate ion is doubled in the from third row to fourth row. So here in the second case, the H2PO2 minus concentration doubles and the rate also doubles. So here we can see in the in the third row we can see the rate is 14.4, and when the concentration of phosphinate ion doubles, we can see the rate become 28.7, that is almost double to that of 14.7. So here we can see when the concentration of phosphinate ions double, the rate also doubles. So the rate is proportional to H2PO2 minus raised to 1. So overall rate is equal to K into a constant into concentration of phosphinate ion into square of the concentration of hydroxide ion. So the total concentration will be 2 plus total order will be 2 plus 1. So that will be 3. Here the correct option is 3, not 4. The correct option is C. Next question. If the temperature become infinite, then identify the correct pattern of the plot ln K. K is the rate constant versus temperature versus 1 by T, that is 1 by temperature, using Arrhenius equation K equal to A e raised to minus EA by RT. So this graph is given here. and the Arrhenius equation is also given here. We want to predict what will be the graph when we are plotting ln k versus 1 by t. So when we are taking the log on both sides, we can say that ln k is equal to ln A minus EA, that is the activation energy by RT. Here we are saying that the temperature tends to infinity. When temperature tends to infinity, the second term EA by RT will tend to 0 and ln k will be equal to some constant. That is ln k is equal to ln A. So we will get this graph, that is ln k versus 1 by t will be a constant graph. A line horizontal to that of the x-axis will be present, that because it is equal to one constant without any slope. So second the B option, that is a line that is horizontal to x-axis, will be the correct answer for this question. Next question. Consider a system consisting of 1 mole of monoatomic gas contained in a piston. What is the temperature change if the gas if Q is equal to some value and W is equal to minus 100 joule, where R equal to 8.31 joule per Kelvin mole. So option A equal to minus 12 degrees Celsius, option B equal to minus 4 degrees Celsius, C 4 degrees Celsius, and D equal to 12 degrees Celsius. Here, the value of Q is equal to 50 and the value of W is equal to minus 100. So we have to find the internal change in the internal energy. So delta U is equal to Q plus W, that is 50 joules of energy is absorbed by the system and work done by the system is minus 100. So the total change in internal energy will be minus 50 joule. And the internal energy is related to the temperature change by the equation, that is delta U is equal to N into F by 2 R delta T. That is the equation for internal energy related to the temperature change. So here, the gas taken is a monoatomic gas, that is only one atom is present, and the degree of freedom for that gas will be 3n. For any gas, the degree of freedom will be 3n, where n is the number of atoms present in that molecule. So it is a monoatomic gas, so n equal to 1. So the degree of freedom for a monoatomic gas will be 3, that is 3 into 1. So here we know that the change in internal energy is minus 50. And we have to substitute this in the equation, that is 3 by 2 into 8.31, that is the value of R into delta T. We want to find the temperature change. So delta T is equal to minus 100 by 3 into 8.31. So temperature change will be minus 4 degrees Celsius. So there will be a decrease in the temperature of the system by 4 degrees Celsius. So the temperature change will be minus 4 degrees Celsius. The correct option will be option B. Next question. For a cyclic irreversible process, the total work done by the system, that is, it is a cyclic process and it is irreversible. That process cannot be changed in the opposite direction. So we want to say for a cyclic irreversible process, the total work done by the system is option A, always positive, B, always negative, and C, or equal to 0, option D, equal to infinity. It is a theory point. This question is from a theory point of view, and the answer is always negative. For a cyclic irreversible process, we cannot alter that system, and the work done by the system will be always negative. And next question, which of the following are not state function? A state function is that that function only depend upon the starting portion, what will be the starting state and the ending state. It will not depend upon the path. And opposite to that is the path function. Path function is that which will depend upon what is the path taken for that process to happen. So in there are 1, 2, 3, 4, 5 processes given here. We want to see which are not the state function, which are the path functions here. So A equal to Q plus W, and B, that is Q, and C, work, that is W, and D, H minus TS, and E, Q minus W. Choose the most appropriate answer from the option given below. And option A and D only are the path function, not the state function, that is path function. And B, B and E are the path function, and C, B, C, and D are the path function, and D, B, C, and E are the path function. So the path function, in thermodynamics, the most important path function defined as pressure, volume, temperature, enthalpy, internal energy, Gibbs free energy, and entropy. And the path functions are easy to remember. That is heat absorbed and the work done by the system. And here we can see in the A option, that is capital A option, here it is Q plus W. Q plus W is internal energy. So internal energy is a state function. So not state function. So it is not the answer. And Q is a path function, and W is also a path function. And D option, that is H minus Ts. H minus Ts is defined as change in the Gibbs free energy. So that is delta G. Delta G is also a state function. So it is a state function, and E is a Q minus W that we don't know. When we check the option A and D, that is wrong answer, because A is a state function. It is not a path function. So the A option is wrong. And B, we can see B and E only, but C is also a path function. So that option is also wrong. And in B, C, D, D is not a B is not a path function, so it is also wrong. So the correct option will be option D, that is B, C, E are path function. It is not state function of so our correct option will be option D, B, C, and E only.